Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome to another episode of the Reliability Matters podcast. I'm your host, Mike Conrad. For those of you who are keeping track, this is episode number 112. Let's face it, our industry survives on electricity. There would be no circuit assemblies, no electronics without electricity. Electricity is the fuel that moves our industry, allows innovation, evolution, and even revolution within the electronics world. We are all aware of the potential dangers of electricity. Electricity in the wrong place at the wrong time can be deadly. Uninvited electrical current on an electrical component or a circuit assembly or even a device can render severe and potentially expensive damage. This uninvited electricity most commonly finds its way through electrostatic discharge, or ESD. Fortunately, our industry is generally well aware of the potential dangers of electrostatic discharge and, over the years, has implemented policies, procedures, and products to mitigate electrostatic discharge and the damage caused by it. My guest today is Christopher Almeras. Christopher began his career in process engineering for a small electronics manufacturer in the late 1990s. There he became responsible for ESD, or electrostatic discharge compliance verification. His next career move took him to a high-volume manufacturer where he added ESD Coordinator to his title. Eventually, he made the jump into military and aerospace side of electronics manufacturing in 2010, where, at Raytheon, works in process capital installations, continuous improvement, and ESD mitigation. In 2009, Christopher completed his ESD Certified Program Manager from the ESDA, Electrostatic Discharge Association. He serves as a member on several ESD Association standards committees, including S20.20, TR53, Process Assessment, High Reliability, Electrostatic Attraction, among others. In 2022, he became the working group chair for soldering and desoldering hand tools. Christopher was elected to the ESD Association's Board of Directors and continues to be active with the ESD Symposium each year. Christopher recently founded Lone Star Electrostatic Solutions, a business which provides its customers with full-service solutions for their ESD needs. Christopher earned his Bachelor's of Mechanical Engineering at Purdue University and his Master's of Industrial Engineering at Oklahoma State University. So without any further ado, let's welcome Chris. Hey, Chris, thanks for joining me today.
Thanks, Mike. Appreciate it.
I have to say, you win the award for best hat in your headshot. That's a cool hat.
When in Texas, you have to do as Texans do, right?
Absolutely. No one could have said that better. I'm a big fan of the show Yellowstone, which of course is not near Texas. It's very north of you, but I've fallen in love with quote unquote cowboy hats, or as you would call them, hats, and that's a pretty cool one. But welcome.
Actually, we call them required attire.
Required attire, exactly. Yes, I agree. My wife turned 60 earlier this year, and we went to Nashville, as one does, right, and terrorized Broadway, and I brought an old Stetson that I had from years ago, and I had to kind of reshape it because it didn't fare well in my closet, buried between, under all my baseball caps, but I got it reshaped, and that was fun. I pretended I was, a Southerner for a few days, and I don't think I really saw the heart of the South, in Nashville necessarily. I saw the tourist version of it, but it was a whole lot of fun. And I do enjoy going to Texas. It's a huge state. But your highways are in better shape than mine are. I'm in California, and one thing I noticed, regardless of where you were in Texas, at least by comparison, your highways were clean and they appeared to be well maintained and all of that. I guess that's one advantage of not living in an environment where it snows and ices up and cracks the road every year and things like that.
We have our share of not so good roads too, but that's what 4-wheel drive trucks are for, right?
There you go. Yeah, hats and trucks. There you go. Well, again, thanks for being my guest today. I've long wanted to talk about ESD, electrostatic discharge. But before we get into that, of all of the specialties that one could choose or fall into within our industry, I've talked to reflow experts and profile experts and soldering material experts and failure analysis experts. What drew you to, or what circumstances pulled you into the whole world of electrostatic discharge?
Honestly, to begin with, I was voluntold into it with doing the compliance verification checks at my very first stop in the industry. And so it was during that time, doing that for a few years, where I kind of got an idea of what what control items go on and or that you need in a typical electronics manufacturer. And then from there, when I made my second stop in the industry, working automotive electronics, we had an issue that some component that kept falling out. And I happened to mention about the potential for it being an ESD event, and with the way that line was set up and stuff. And turned out I was correct about that. And so the company was like, okay, well, we don't know much about ESD, so go get training on it, because you appear to know more than others. And so, that they tell you to go get training, sure, why not?
Sure.
They were paying for it, and it as you get further into it, you realize how much there is to it. It's not just black and white. There's a lot of gray area. There's a lot of if you're someone who likes challenges, puzzles, whatever, that's basically kind of what you're dealing with when you're trying to figure out an ESD issues. And it's a challenge, and so I've enjoyed it.
Yeah, I'm sure it's been quite a ride. That's how this industry is. You kind of get sucked into it. And, when I was a young teenager, I didn't dream of being in this industry. I didn't even know of this industry. I just thought electronics showed up one day, brought by a stork or something. You just don't know what you don't know. And here we are, in my case, 37 years later, I'm still in this industry. I've said this on the show before, but this is a life sentence in this industry. When you go to trade shows, you see the same people. They're wearing different badges and standing in different booths, but people seem to leave the industry in either a box or by winning the lottery and buying an island somewhere. They don't generally leave. If they do, it's for a short time and then they're back again. It's Groundhog Day in many
Yes.
respects. Yeah, I'm
Yes.
sure that's been your journey too. So for the sake of my audience, the majority of my audience is in this industry and electronic assembly and EMS world and all that. Not all are. So let's just not assume anything and kind of begin with a beginner's mindset. Tell me what electrostatic discharge is and the damage it can impose, from a 30,000 foot level. Give me a broad description of what ESD is and what it is we're trying to mitigate.
All right, so ESD is just basically charge builds up onto an object, right? And it's just the transfer of that charge from one object to another. It's just your basic science, the things you hopefully were learning in middle school science. For those our age, I think kids these days probably learn it in first grade. But basically, when that charge builds up on an object during our processing of electronics, if it discharges or jumps to a component or a assembly product, it can do two types of damage. Basically, latent damage, it's damage you see a little bit later, usually shows up during the functionality at some time, or catastrophic damage, which makes the part not work basically at all in the beginning. And it's due to the sensitivity levels of these components or assemblies, which are, as we've gone over the last 20-25 years especially, these assemblies keep getting smaller, and more powerful, especially like cell phone industry and that kind of stuff. And so it's just basically the movement of electrons from one object to another is really what ESD is. Just in our case, it can be very dangerous.
Yeah, you mentioned two types of problems, latent damage and catastrophic damage. I would assume latent damage is more insidious. It's a worse problem only because you don't know you have a problem. Maybe you plug something in, you're not wearing your wrist strap, or you touch something without your wrist strap, and you go, oh, shoot, or something equivalent, and you test it, and you go, oh, phew, it's working. But the damage may already have been done, right? It may have weakened something in the system or created a situation where something maybe later won't calibrate properly, as opposed to poof. When you get the poof, the catastrophic damage, you're in trouble, but you can fix it before it goes out or replace it before it ships out. Latent damage is a time bomb in many ways, right?
Yeah, and sometimes you see your latent damage at test and don't realize it. It can be as simple as resistance value has shifted just a little bit, but it still falls within the tolerance of what your test may be measuring and stuff like that. So and it just drifts out over time. Especially the more the assembly is ran in whatever its end use is, and that can be frustrating for customers and stuff. That it seemed to work when I first got it, and then now especially in the military aerospace field, it's expected to work at all times, and you get something year and a half, 2 years down the road, and all of a sudden it's having just these little issues and not functioning fully, and that becomes a huge problem for our customers and can become a black eye for any of us in the industry that's producing that kind of stuff.
Yeah, for sure. It could be an instant RMA, which is costly, or it could be damage to the reputation. Unfortunately, damage to the reputation is hard to put a price tag on, right? Because you don't know. Right. You're the last to find out. As the old adage goes, like a product, tell one person. Hate a product, tell 100 people, right? So word gets out.
Yeah. With social media, that turns into thousands and thousands of people very quickly.
Oh, yeah, sure. Absolutely. So you're on the board of directors, as I mentioned in the intro. You're on the board of directors of the ESDA. I assume that stands for Electrostatic Discharge Association, right?
Yes, that's correct.
Okay. Well, it didn't take too many brains to figure that one out. Tell me more about the ESDA. What are its services? What benefits does it provide its members? What's it all about?
So basically, the ESDA, they provide actually multiple services. They are let's call best way I can think of describing as the caretaker of the standards for electrostatic discharge. The ES 2020 standard, which is basically the Bible on how to set up your factory to protect from ESD events happening at least to a certain level. Also TR53 standard, which is the test methods for compliance verification of your control items, your ionizers, flooring, those kind of things, along with a lot of other documentation. You mentioned some of the ones I'm involved in, the TR17, which is on process assessment. This year released the TR19, which is on high reliability. It's extra steps you can take to protect, you can call it more valuable product if you want. And then, beyond the standards and documentation, the ESD provides training. They provide training to TR53 to certify technicians to be able to do your compliance verification. They provide other informative things. They have tech talks online and stuff discussing like the technology roadmap and different things like that. And then, of course, every year they put on different workshops, and the ESD Symposium. And the ESD Symposium is really a good. It's a great conference to be at, to learn a lot, because there's so many people that attend that have been in ESD for a long time, and it's valuable to be able to pick their brains. But they do wonderful workshops on at the symposium on different things. From, we did one this year on process assessment, where we actually had a piece of equipment, as just a little automated handler. Actually, two of them where we did a demonstration on, what are the things you would check to try and, make sure that this wasn't, creating any kind of danger to your electronics or components and that kind of stuff. A lot of papers are presented, and also, just other, discussion topics, on just some of the latest things going on with ESD stuff. And there's also a design side to it that's more catered towards those who are doing the design of components and circuits. So we do a lot of things.
What I find interesting, two things. It's a little bit ironic that the Bible, the ESD Bible, you refer to that as 2020. And of course, we've learned a lot about ESD through 2020 hindsight, right? So it's kind of ironic that, particularly in the case of latent damage, as we discussed earlier, that's a 2020 thing. We don't realize it at the time. We realize it when we look back, maybe the mistakes we made. Also, what I find interesting is that there are still standards being revised and designed for ESD. It's, from my standpoint, I don't know much about ESD except, wear your wrist straps, your heel straps, all that stuff, right? Always be grounded, don't be floating. And yet there's so much more to it. And the fact that there are revisions to standards and new standards and things like that tells me, and that there are conferences that people attend that have been aware of ESD for generations, tells me that A, there's conferences so that when new people come into the industry, they can get up to speed, and B, it's a little bit of a moving target, that perhaps miniaturization, as you mentioned earlier, and other factors that are part of the evolutionary process of electronics are changing the ESD requirements. They seem to be getting tighter and not staying, pardon the pun, but it's not static. The standards are not static. They seem to be evolving. Is that due to, obviously, things like miniaturization, as you mentioned, but other factors as well?
Well, miniaturization is really the key. When the S2020 was first established, it set that, hey, this is telling you how to set up your factory to be able to handle any components that have sensitivities down to 100 volts human body model, and then 250 volts charge device model. And while that works for the longest time worked for well over 95% of what anyone would be handling in our industry, miniaturization is creating more sensitive components, down to 50, 25 volts human body model that, can be damaged by that, and lower CDMs and stuff. And so because of that, we're always having to, what are test methods to be able to keep your controls able to meet if you have that kind of susceptibility, right? And then, there's, just like any other industry, there's improvements that are made, especially on the on your test and your measurement equipment. For the standard ionizer test is, you have your decay time, and also a balance check. Well, there's companies out there that are working on making that easier to do, a little more, besides easy, just, less time consuming than necessarily the old charge plate method, and stuff. And so because of that, you got to start working that stuff in once it becomes, kind of set in stone that, hey, this does give us information that we need and is consistent. and stuff. And then with the process assessment, high reliability, those are ones that are really kind of filling some voids that we've had from documentation over the years. It's doing a process assessment to, hey, this is what can my process handle from a component sensitivity standpoint, right? There was not much information out there, and what there was usually in different technical papers or in different areas, and did not have a lot of the background information possibly needed on, what to go and do, what, the important parts of the measurements, what things to look for. And the document still doesn't have all that. There's still other holes kind of we need to fill, but a lot of it here recently over the last 5 years has just been trying to find those gaps in the information that we're providing to the industry, and trying to fill those with, proven methods and useful information. Because really, we're all in this together.
Yeah, that's right. In my world, I'm in the cleaning world in my day job, and miniaturization is our best friend because for the same reasons. As things get closer together, the amount of residue that an assembly can tolerate is far lower than it would be when we were all in the through-hole days. And I would imagine for the exact same reasons, ESD is now more critical on miniaturized components because it doesn't have to go far between one component and another, and they're more sensitive. They're densely packaged, and they're more sensitive components to ESD and contamination and probably other things as well. A couple of real quick anecdotes. I think when you and I had a conversation a week or so ago, I probably mentioned this to you, but for the sake of my audience, I got into this industry in 1985. I was 25 years old, and I had never seen an electronic assembly environment before. I came from a completely different industry, so I was very green. And I was on the shop floor, and they had all of us strap up. This is, I don't know when ESD was first put on the map as a major concern, but this was probably the earlier days of ESD. And it was the most archaic system I'd ever seen. And fortunately, it was the only shop I've seen that did this. But I thought, everyone does this? There's got to be a better way. They had a series of tight wire cables hanging from the ceiling, almost like these electric streetcars that you would see like in San Francisco and a few other cities. And attached to the cable was a solid metal ring, pretty heavy ring. And hanging from the ring was a cord which attached to a wrist strap. So these cables were every so many feet, like down aisles, and they would go X, Y. So they would be north, south, east, west cables. And people would walk from one section of the factory floor to another, dragging the cable attached to the ring, scraping along the tight cable, and like they were connected like a streetcar. And if they had to change directions, like go north for 3 aisles and then make a left and go west for 3 aisles, they would have to grab another cable from another wrist strap connection from another cable connected to a ring on the other wire, and then start traveling that way. And as you can just imagine the noise all this made as people were walking up and down doing their thing, dragging these hard metal loops across a tight metal cable. And if you were to pass somebody, if you're going north, someone's coming south, you had to, once you got face to face, you had to swap wristbands so that you can keep walking. It was the most archaic thing I'd ever seen. And I'm like, this electronics industry is not that sophisticated, but I guess that was a quote unquote poor man's ESD control. They didn't have any ESD flooring back then. And the other funny anecdote was also in my early years, I went into a facility that had ESD floors, and they handed out heel straps, to put on. And then they had a little tester before they let you in the room. You had to stand on this tester, and it would give you a green or a red or a yellow, whatever it was. And, I passed it, but someone I was with kept failing. And our escort was like, did you attach the heel strap properly? He goes, yeah, shoved it in my shoe. He goes, well, I don't understand why. Let me see it. And it turned out he took the whole wrist strap and shoved it in his shoe. The whole thing, the heel, the everything, and shoved the whole thing in his shoe. And couldn't figure out why he wasn't passing. It's like, might as well have just put it in your pocket, right? It was just as effective. But, that's an example of somewhat following directions, but not understanding the spirit of why we're doing that. Not understanding the concept of grounding, not understanding how electrons flow. They just did what they thought they were told to do and thought everything would miraculously be okay. And of course, he never got past the door, until he got that fixed. But my early introduction.
We still see some of that stuff today. I mean, as much training as a lot of places go through, I live it on a daily basis where I see straps put on wrong, or just things you think your procedure and your training is clear, and to some people it isn't, and so you get to go back and make another slide or whatever to try and convey what really needs to be done.
Training just got 15 minutes longer now. Thank you very much. Right. Yeah. And we're going to get into that a little bit. That's my favorite topic on the show, is talking about things that fail, that go wrong. But we'll get into that in a few minutes. For many people that have a basic knowledge of ESD mitigation, that is a wrist strap, maybe a heel strap. They don't touch things unless they're grounded. What other, in addition to flooring and human grounding, what are some of the other ESD mitigation techniques or devices or procedures that protect the products we make and the products we use?
So I mentioned ionizers briefly earlier. Ionizers is a very commonly used to remove charges off of product or other items. So basically, there's kind of multiple ways to go about it, but you're either wanting to remove charge from everything that could come in contact with or come in close proximity with your sensitive devices, or use materials that will not charge up and will not discharge. So there's a couple ways you can go about it. You've got your control items, your ionizers, your grounding, and stuff like that. But key item is that sometimes gets overlooked is the materials you use throughout your process. Right? If you use materials that won't charge up any of your devices or won't hold the charge, in place of contact, or as we like to also call, put in soft landings, as I like to call them, where, when I'm working on a circuit card or whatever, your typical workstation with your ESD mat that's grounded, that usually provides a soft landing because there's some resistance to that ground. Usually, the mat is 10 to the 6th or 10 to the 7th. That way, if there is any charge on your product, it's going to slowly drain out and not be a very fast drain out, which, can cause damage. Several people have seen, besides myself, have ran into it before, is where people are like, well, I have a metal table and I grounded it, and they just did a straight ground wire, no resistance to it, and then found out that, hey, placing a board on it that had a little bit of charge to it, created an event, because it drew all the charge out of that board so quickly because there was no resistance going to ground. So
we were guilty of that years ago. We came up with a new product that had the need to be ESD safe. Products were put on top of this workspace, and we decided to put a stainless steel worktop on it. I figured, wow, that very few things conduct electricity better than metal. We'll put a metal top on it. And we thought, and then a place to plug in, no resistor. We didn't have the concept of soft landing. We just, kind of like the guy that stuck the heel strap in his shoe, the whole thing in his shoe. We just thought, okay, it needs to be grounded. Perfect. Put a meter on it, and it's 0 ohms of resistance. This is great. You can't get any more grounded than that. And then we got a call once from an engineer saying, this machine didn't pass our ESD audit. I can't understand why. Maybe you didn't ground the machine. He goes, no, we ground the machine. He goes, the problem is it's too good a ground. There's no resistor. You need whatever K resistor, whatever it was. I don't remember. But that was a hard lesson for us because we thought we were following the spirit of the rule,
Right.
But we didn't follow the letter of the rule, and that could have, had we not remedied that, and it was an easy remedy. It was a 10-cent fix on every machine, but that could have led to potential damage of customers' parts, without knowing the full story.
Yeah, and so those are, most places I've dealt with and been in, they understand, the basic control items, your workstation, your wrist strap and ionizers and stuff like that. And where they struggled as from a knowledge standpoint was, what materials to use elsewhere. They had, equipment where they're using metal fixtures to hold their circuit cards that, the card set down into, and the whole back of it and all the test points and other stuff were touching metal. And then that metal fixture is running across a conveyor belt that's kind of charging up, and then boom, it contacts a stopper in the machine that's going straight to ground. And, there's so many things. It's like I said earlier, it's a challenge. It's a puzzle. There's so much to look at and fit together, because as much as I sit there and say, oh, well, you want a soft landing and stuff like that, there can be situations where you don't want that soft of a landing, or, but material selection is extremely important. And, if you have good material selection, then that's half the battle, with, charge accumulation being the other.
So let me ask, going back to that subject of a stainless deck versus an ESD material, laminate of some sort, are the materials, the non-metallic materials, is the discharge rate, the soft landing, as you say, built into the material itself, or is that still protected with a resistor?
So it depends on the material itself. Some materials are, naturally in the dissipative range, but even with that, it may be in the dissipative range, but you don't want it to be floating. You still need to attach it to ground in most cases. And so it's a lot of it has to do with what you're doing in that process at that point, on what is the best route to follow for setting it up to protect your components.
One interesting term, which to me sends a message that your job will never go out of fashion. You have workplace guarantee, forever. Is I've never heard anyone say ESD prevention. I always hear ESD mitigation or ESD control. It's that leads me to believe, even if we control it to the point where it doesn't cause damage, it's still there. There will always be electrostatic discharge. The sole purpose of electricity is to find ground. It wants to get, lightning shows us that. It wants to get to ground. And it's going to find a way there. And I think, correct me if I'm wrong, but the whole purpose of ESD control is to have a controlled landing, a safe landing, one that doesn't cause damage. But there will always be ESD. We can't prevent that. Is that a oversimplistic way to look at it, or is it accurate?
I don't think it's an oversimplistic way to look at it. I mean, trying to you're not going to be able to, as much as we would love to, you're not going to be able to eliminate all charges off everything. I mean, charge accumulation comes from contact and separation, right? And while some materials, hold more charge through it than others, it's going to be there. Just when a person just walking, example that everyone knows. I mean, your clothes are rubbing up against your body, and just the your feet touching the floor, then removing from the floor, that kind of stuff. You build up some kind of charge, and it's different for everybody, different for each material. Depends on the combination of what materials are coming together and being separated and stuff. So yeah, it's a fantasy to be able to eliminate all charge. In my opinion, you can do your best to eliminate as much as possible, but that's again where material selection comes into play. It helps you reduce the amount of charge that can accumulate in the areas where you would be most susceptible to damage, right? And those are the key places to try and eliminate it from. And when you can't eliminate all of it, you need to provide a soft landing or way to drain the charge out from whatever it is that's charging up before it can damage any of your sensitive components.
Right. Let's get into the fun part. Let's talk about ESD fails. I shared a story or two. Even at companies with an ESD program, I'm sure there are some common mistakes, some common denominator mistakes, and maybe even some very random mistakes that people make. What do you see in your line of work with all the experience you've had? What are the common mistakes and maybe even less common mistakes that you see people make time and time again?
A lot of it's really just the human element of it. And that can come down to, not fully understanding what, the potential cost to ESD damage. It seems like, it's multiple times a year that, somebody didn't strap up, whether as their heel straps, wrist strap, or whatever, didn't follow, one of the procedures to go with our ESD controls and handled product, right? And then you're having to go through and try and exonerate that product, trying to figure out, okay, did this person what's the chance that they caused damage to what they handled? And that's part of where you want redundancy in your control items, right? You're the operator strapped up and they're working on a grounded mat and have an ionizer on, and they're wearing smock and using tools and materials that are non-charging, whatever, and to where you can be like, okay, well, didn't have the wrist strap on. Okay, well, this and this help mitigate, so our max potential of charge was X, and so because of that we feel that there's very little risk to what they were working on due to the sensitivity levels, that kind of stuff. So human error is probably the biggest one, and as much as we try and eliminate that, we all make mistakes, we all have our head somewhere else at different times, and so it becomes common. And then the other things I tend to see are when people they have a base understanding of ESD and or other things, and it's like, well, we if it's grounded, things will be fine, or if one ionizer works well to remove charge off of something, well, then two ionizers will work even better.
More is better.
That's not always the case if you got the airflow crossing, stuff like that. But you and I discussed this before on our phone call a couple weeks ago. I did have one years ago one company I was working for, a plant in another country, got a call from them saying, "Hey, we're seeing all kinds of issues on first shift, where we're getting all kinds of fallout at ICT tester. And it's this, same components, first one tested, and it's like we're at like 40% failure during, first shift. But it's like after lunch, it just goes away." And so they weren't letting me travel to review things like that at the time. And so it's like, okay, well, send me a flow chart of your process. Where does that component get placed? All the steps between it and to where you're finding it, ICT. And then I want you to take pictures and send it to me. And so I'm kind of going through the process and flow chart, and I'm looking through the pictures, and it's like right there at the ICT, it's like I see there's storing assemblies. They had cardboard boxes that were stacked up sideways, and they were storing the assemblies there. And I'm like, cardboard doesn't usually, that doesn't charge up, unless there's some kind of coating on the cardboard or whatever. But it seems like a little bit of a FOD issue. So I get him on the phone, and I'm talking to him about it. I'm like, "Hey, I noticed you're storing this stuff in cardboard." I'm like, "There are some concerns about FOD." So
Which,
then they're like,
for the sake of my audience, FOD, foreign object debris, right?
Yeah.
Okay.
Yeah. So they're like, "Yeah, well, we thought about that. So, the reason we're using those is we're waiting on the racks we ordered to come in. They were on back order, should be in like another week or two." They're like, "But we thought about the FOD. So, to, keep any shavings from the cardboard or whatever, we put down saran wrap."
Huh.
I was like,
solve one problem.
Okay. Yeah. So what was happening was these assemblies were coming out SMT, over 3 shifts, and they were only run this ICT tester on first and second shift because it ran a little bit faster than the tack time in SMT. And so the stuff they were on third shift was getting put on these saran wrap cardboard boxes and setting on saran wrap, which, holds a very high field of voltage, and it was charging these boards up. And the longer they sit there, the more charge they would get. And so the first ones they were testing in the morning, they were killing a component. And that's why they got after lunch, and they were getting them straight from SMT, and they didn't have as much time on the saran wrap.
There's something funny. There's something mysteriously funny about third shift. Our greatest horror stories from a service perspective for our equipment comes in the morning when we come into the office. We've got emails or voicemails from something that occurred at 3 o'clock in the morning, and it's always third shift that has the most interesting service cases. I don't know why. I don't understand what it's like, the witching hour or something, right?
Yeah, all the gremlins are out. So yeah,
that's for sure. I'm sure you've had your share of ESD audits, if that's the correct term.
Right.
What's your experience during an audit? What kind of things are you generally looking for when you do an audit? Walk me through a generic audit.
Well, just a generic audit, depending on what you're auditing. There's a couple different audits that I've done myself or personally do. You have your typical audits that are to your documentation, right? Of, what's your ESD control program plan, right? So, it states, okay, your ionizers, flooring, your workstations or whatever are going to be verified, every 6 months, right? And, so you're making sure that's being done. You're making sure that, hey, operators are supposed to be wearing a wrist strap when working, when they're in a seated position, right? So are they doing that? We have a list of materials that is allowed within proximity of the product, right? Usually within 12 inches or whatever. You control that, so you're looking for anything that isn't supposed to be there, right? Especially charge generators, your plastics, things like that. So those are things in a typical audit. Well, hey, you're checking in your heel straps, right? Let me see the record of that to make sure that everyone's checking, right? And you have the digital ones now that record and stuff like that, and that's kind of made it easier. But then on the other side of it is I've done for others, but I'll also do in our factories is really kind of a process assessment or a process audit, right? And that's a little more in depth of taking a look at especially with automation, taking a look at really is the equipment that we're using to process our components, does that still meet our ESD requirements? There's so many things that can happen over time as a machine runs, right? You had good contact, to ground when you first got the machine in, but because of wear, now you don't have as good a contact because of PM. Maybe, somebody was heavy-handed with the grease gun in some areas, and now you don't have the, kind of ground contact that you would need to try and mitigate things. And I've seen, it's actually a case study I presented at the ESD Symposium in 2018, where a fixture nest basically was used in the stencil printing process. We use those nests to just basically pull any voltage off the board during the paste process. Well, they used a different coating on that, a different type of iodine that didn't allow for it to ground out properly. So we weren't removing voltage from the boards, and so these bare boards, and then some of the first components that were placed were getting lit up by about 3,500 volts, and some of them couldn't handle it. So just looking at material selection, what your process can handle is another audit. So
I'm sure there's been cases also where someone grabbed the wrong bottle of wax and applied nice shiny wax to the ESD floor and basically laid down an insulator. Have you seen that happen?
I know of that happening. I haven't seen it for a while. We did have a case where one of the cleaning crew had come back from lunch and had their bag hanging on their cart, and was pushing through one of our areas, and a ball of hot sauce fell out and busted on the ESD flooring. That was a third shift thing.
There you go.
And, so we had to kind of figure out how to get that area to be, meet our requirements again after getting the hot sauce cleaned up and getting that orange stain from that floor was.
I guess it's good to know that the hot sauce. I love hot sauce on everything, and it's non-conductive hot sauce, I suppose. So.
All right.
Yeah, I'm not going to get shocked by it, but it's not going to protect from an ESD standpoint.
Yeah, it only changed the flooring, by 1 or 2 orders of magnitude. I think we went from 10 to the 6th to 10 to the 8th in that area.
Yeah, well,
which was still
measurable.
Fine, but
yeah. So, do you have I recently interviewed Tom Riccadelli, who is a ESD flooring provider, and there's different types of floors. There's these interlocking floors that you can put down in pieces. There's large sheets of laminate that can go down. That's ESD safe or safer, and then there's coatings that you can apply to an existing floor. Do you have a preference on which type of, if you were building a factory where you were building products where people's lives depended on it, would you, and money was no object, would you drift toward one type of flooring technology over another from an ESD perspective?
I would actually call Tom because him and his company, they they know their stuff. But I mean, there's, here in Texas, in North Texas, we've got, people don't realize it, but there's a lot of ground moisture. And that causes problems because it gets so dry during the summer. It draws that moisture up from lower in the ground, and that causes issues for different types of ESD flooring. And then, so, it's all dependent on the environment it's going into, and, kind of where the factory is, where the kind of flooring that I would personally put in, somewhere in Minnesota would probably differ from here in Texas, and definitely differ from somewhere in maybe Southeast Asia, where you have a lot more humidity and stuff. And then, of course, depending upon what you're building. But that's, while I have my thoughts on, I kind of prefer this flooring, or maybe that flooring, getting the opinion of guys like Tom, is definitely the way to go, because there's, in fact, actually, for one of our areas, we're having to put down some flooring here recently, and I had a discussion with Tom about it, and said, well, we have a habit of, we've put this flooring down in other areas, so facilities is just going to put that flooring down again, because we have a bunch of it. And so, I talked to Tom about it, and he's like, oh, well, have you thought of this, or have you thought of this? Right. So it's always things you can learn, and so my first thing I'd call Tom, actually.
Call Tom. And for my audience who may have missed that episode, I don't recall what number that was, but I'll put a link to that episode. It was Tom Riccadelli, and he is an ESD flooring expert. He, unlike Christopher, who has a wider expertise in all things ESD, Tom's specialty was flooring. And there are many ways for electricity to get into your product. One is through the floor, and I'll put a link to that replay if you're interested in getting more information on flooring best practices. The other thing you alluded to this, geography plays a role in ESD mitigation. Yep. Generally speaking, is a more moisture-rich climate, say, does Malaysia have, now keep in mind, when you're inside a factory, theoretically, heat and humidity are all controlled to a pretty universal level, but not in every case. I've been in many South Asian and Asian factories where I swear they don't have air conditioning. It was miserably hot and sticky. Is a moisture environment generally better for ESD, worse for ESD? Is a drier environment, more arid environment, better or worse?
Generally, a more moist environment, let's say in the 40 to 50% humidity range, is going to be better on ESD controls for you, just because as humidity gets lower, there's the opportunity for, charge generation becomes greater with certain materials, especially, your insulators and stuff. And that trend, there's the graphs and studies out there, that trend goes down to, about 12% is where that kind of flatlines. And as you go below 12% on humidity, there's really no difference. And so that's why, as 2020, and, standards for, if you're doing a material testing, that's where they tell you to do, the material testing at 50% humidity, and then at, 12.5% to make sure it works, whatever material you're using for material handling or whatever you're using it for, that it works at those lower humidities, because there is a difference. Doesn't mean that if you sit there and raise your humidity level to 75% in a factory that, all will be good and you won't have to strap up, things like that. It just, it does help with some of the charge accumulation. But it's, and you see there's plenty of customers that have strict requirements on, hey, if the humidity drops below 30%, you're not working on our product, right? So yeah, there's some benefit to that.
Yeah, that's kind of an avenue I hadn't considered with that question. My question was more aimed toward is ESD worse in a humid or dry environment? But in addition to that, and you answered that, in addition to that, the ESD mitigation tools may work differently at in a different climatic environment. Floor sealants and other materials that are used to control ESD may have a different controlling benefit at higher or lower humidity levels. That makes perfect sense.
That's where material selection,
right,
comes into play again.
Right.
It's so key to everything you do. In there, you can have great controls and stuff, but if you forget about your material selection part, you're fighting this fight with one arm tied behind your back.
Sure.
In my opinion.
And if you do have higher humidity, you may, in general, have less propensity for electrostatic damage. However, you will have a line of employees leaving your factory if you're making them work at 75 or 80% humidity levels. That would not be a pleasant
Either that
experience.
Or they take the ionizer and turn the heater on if it has the heater option, and then they blow it straight at themselves instead of on the product.
Right. Try and dry it out a little bit.
Yeah.
Are there certain types of components that are just known to be poster children for ESD damage more than others? Are there certain components that are inherently more robust and other components that are just uber sensitive to ESD?
But typically your caps and resistors, right, or there's not as much to them there, right? But
that would be more on the robust side.
Yeah, more on the robust side, but you still it takes a little more voltage to do anything to those, and though your flip chips, your BGAs and stuff like that, depending on what that package is doing, what the design purpose is, what the size of it is, is there a lot of, is it a power application or whatever. And so I think, 20 years ago, it was a little bit easier to point to and go, okay, well, hey, BGAs, those are, a little more susceptible than other things. But nowadays it's most every package, as we continue towards miniaturization, right? Further miniaturization, it is becoming more and more susceptible. And, it's where having a good relationship with your those who make your components for you, to where, hey, listen, guys, we're getting this component from you. What is the sensitivity? Did you guys actually do that testing on this component, or is this based off of a similar component you've done testing on? Those are, things you got to communicate with your suppliers about.
Right. Let's take this beyond components. When we're putting boards together, when we're assembling boards, of course, we're concerned about components. We're concerned about the board and the components on the board. That's the whole purpose of ESD mitigation strategies, is to protect those components from electrostatic discharge. However, for many people who aren't in our industry, who are simply using the products we build, there is also an ESD concern. And a colleague, Daniel Bogdanoff of Keysight. Keysight is the spinoff, for those who aren't aware, Keysight is the spinoff of Hewlett-Packard. Hewlett-Packard made everything from printers to oscilloscopes, and they spun off the test instrument division and called it Keysight. And they sell test instruments that are $150,000 or more dollars. They're not cheap. They're not $1,000 oscilloscopes. They're supercomputers in a box. And he produces he's a fellow content creator like myself, and he produces content for Keysight. And one of the ones that caught my eye, and I'll play just a little 20-second clip from it, was entitled 4 Ways to Destroy Your Test Equipment. Here's what it looks like.
You've probably heard the phrase treat yourself, but if you want to blow up your equipment, it's time to float yourself. Throw caution to the wind. If your feet aren't buried in wet sand at the beach or your wrist isn't shackled to a properly grounded ESD mat, odds are you're high voltage, which is the perfect way to blow up your test gear. I can charge myself up just by walking around, and then we can watch this charge transfer into the board. If I'm grounded, it doesn't happen.
Well, he's very entertaining. I don't think I'm quite as entertaining as that, but he's got a good staff behind him. But the point is, as he was making, you could ruin or at least severely damage a very expensive priced piece of gear, in this case test equipment, by not being properly grounded yourself, and the devices you're testing not being properly grounded. And that's one way to get a few thousand volts into something that's not designed to handle a few thousand volts, and that could be a very expensive proposition. In your experience, where you're watching over the ESD protocols of a company, has your experience drifted outside of just the assembly process and also into the use side of that business as well?
Yeah. One of the biggest issues that everyone really deals with is cable discharge, right? And a lot of these units, especially in military and aerospace, you've got these box builds with multiple bayonet connectors that you got to plug into a harness or some kind of wiring cable, and if the precautions aren't taken to ensure that the cable itself's not charged up or the box itself doesn't have some kind of charge, you can do a lot of damage. And even if it's just a single component, the cost of having to take that box apart, get to that component to replace it, sometimes there's boards attached to boards that are and attached with metal cores and stuff like that, and it's just not a easy, okay, well, I undid 4 screws, took the lid off the box, there's that component, I took my soldering iron, I removed it and put another one down, and a little bit of solder, a little bit of flux, and hey, we're good to go. I wish it was that easy in all cases, but 99% of the time it's not. And that we run into that at different times. There's plenty of process assessments or reviews I've had to do over the years where on the, I'll call the back end side of the process, once they start putting together multiple assemblies into one box build, where they felt they had some kind of issue. So it's more common than I would like it to be.
Yeah, I'll bet. So compared to when you first got into the ESD side of this business and today, have you seen any significant improvements in ESD mitigation technology? Or is it the same basic mitigation methodologies, just applied maybe more stringently or maybe better monitored? Are there newer advances that have been made over the years?
Well, there's been advances, and even though those advances are on, our basic tenets of ESD control, right? The ionizers 30 years ago, your balance, hey, listen, this ionizer stays balanced, plus or minus 25, that's great, right? Now you've got ionizers that, are balanced, plus or minus 5, plus or minus 2 volts. Right. So, a much tighter window, which, disk drive industry and all that stuff, is very important to them. With the grounding, you mentioned about monitoring, when I first broke into the industry, there wasn't a lot of monitoring of your wrist straps. Now, many places have constant monitoring, but even, 10, 15 years ago, some of the constant monitors you could fool. I had instance where, walked up and there was an associate that was working on an assembly, and their wrist strap was laying next to him on the workstation. It was still plugged in, but the cord was all bunched together and they had rubber banded around it. And the reasoning being was, well, the constant monitor kept beeping at me when I had it on. And when I took it off, though, I kind of in frustration crumbled the cord and it stopped beeping. So, it was, it would, that was, there was some constant monitors that you could fool in that way. And there was some that, didn't do well with if you were, instead of connecting through a wrist strap, if you were connecting to a smock. There's some that the groundable garments, and there was some I tested that I'd plug in the groundable garment and I'd hang the garment on the back of just a regular chair, and that constant monitor would never tell me that hey, you're fine, right? I mean, we've come a long way. I can't say that there isn't still some out there that maybe you can fool in some different ways, but it has become a lot harder.
Reminds me of putting black electrical tape over the warning lights in a car. It's like, I don't see it, it's not there, right? It's not beeping at me, it's not shining a light on my face, so no problem.
That's true. Well, and typically though, the operators, in my experience, have done a wonderful job of finding these creative ways to circumvent controls, and
right.
It never ceases to amaze me the creativity that in the some of the steps they'll go through to come up with some of the stuff.
Once again, more job security. As we end up, my last question: tell me a little bit about Lone Star. You've done the most insane thing. You started your own business, and I say that because I did that 30 years ago. It's a fun ride. Tell me about Lone Star and what its purpose is, what its services offered are, and why you did that.
So why I did it was after years of working with ESD, with multiple companies, and being involved with the ESD Association. Been asked multiple occasions by people, hey, can you come take a look at this for me? Because what you're doing with ESD and stuff, and it just felt like the right time to go ahead and start a company to offer services such as training, whether it's, hey, need someone to come in and train people on whether that's just your basic ESD controls, if it's writing the training to your control program, or even writing a control program for you, or setting up your control program. We offer that compliance verification. I can come in, do your verification of your control items, process assessments. Hey, what can our process handle? Material evaluation, those kind of things. So basically, trying to offer is much help from an ESD standpoint that a lot of companies need, and I think it's more important now than it's ever been, because we've continued to beat on miniaturization, and the susceptibility of components and assemblies just continues to go push further and further towards zero. And while it's not affecting every electronics assembly or component, it's affecting more and more each year, and that trend is just going to continue to go towards zero. And then with the CHIPS Act and the push to try and bring more electronics manufacturing and semiconductor business back into the U.S., most places don't have true ESD subject matter experts.
Right.
Kind of like was thrown on me, you seem to know a little bit about ESD, so you can handle it, right? Well, maybe not everyone has the ability to go get the training necessary to get someone, in-depth knowledge of what needs to be done to help protect their product. And so, with there not being, I want to say that there's a lack of knowledge, because it seems like every year there's more and more people getting involved, but still there's a lot of companies that have very little knowledge and could use help. And Raytheon and other places I've worked, we've we've got subcontractors that do some of our work for us and stuff. And so it's important that, these places, have a resource for trying to help them get their ESD program to the, best place they can be. And, sometimes it's, as a business owner and from what you've seen is there's that whole, cost analysis, right? It's going to cost me this much to get somebody, trained up, and what's our risk, what's that going to cost us and stuff. So, based on a couple of things, I decided to, finally start, my own consulting business on the side and, offer my services to try and help anyone that needs it with, whatever they need from an ESD standpoint.
No, that's great. That's a wise move. Fortunately or unfortunately, a lot of ESD products, and I'm thinking mats and wrist straps and things like that, are commodities sold by, large distribution companies that sell everything from, quite literally kitchen sinks to plumbing fittings to ESD control devices and soldering irons and whatever. Mm-hmm. They are probably good at the distribution model. They're probably good at economy of scale, getting you certain things at good prices, but they may or may not have subject matter experts in the topic of ESD on staff. They simply can send you a data sheet. And I think a lot of manufacturers, when we first started, we were on our own. We didn't know much about it. We knew ESD was a thing. We knew that we needed to have ESD mats and wrist straps, but we really didn't understand anywhere near the complexity of ESD. And the people who sold us stuff simply took orders, and they sold us whatever we asked to buy. And they didn't really speak, they didn't offer an education, but nor should they. That's not their job. So that's a good business model to be able to provide your knowledge to customers. And speaking of that, for my audience who is listening, if you'd like to get in touch with Christopher, his contact information will be in the show notes. So if you're listening to this on Apple Podcasts or Google Podcasts or Spotify or iHeartRadio or wherever you get your podcasts, look at the show notes and on your app, and you'll see Christopher's contact information. If you're watching this on YouTube, right down here, there is a Show More button. Click that, and you'll be able to see Christopher's contact information. And I'm sure you won't have any problem with people reaching out to you.
Not at all. I'm happy to just, even answer, simple questions. If people are just looking for a recommendation on something, or, hey, we're seeing this, what do you think about this? Should we, implement, more ionization? Should we implement this or whatever? And in these kind of situations, happy to try and provide some guidance where needed.
Well, that's amazing. Well, I appreciate that. I'm sure many in my audience will appreciate that as well. And Christopher, thank you so much for being my guest today on the Reliability Matters podcast. I really appreciate you being here, and thanks for sharing all your knowledge.
Thanks for having me. I appreciate your time.
Well, that's another episode. Thanks for listening or watching the Reliability Matters podcast. Don't miss an episode. Subscribe to Reliability Matters on Apple Podcasts, Google Podcasts, Spotify, or on our newest channel, Amazon Music, or virtually wherever you get your podcasts. A special thanks to Circuit Assembly Magazine's PCB Chat at PCBchat.com and Ascendo Reliability at reliability.fm for syndicating this show. Thanks for your questions and episode suggestions. Please keep them coming. Send comments and episode suggestions to Mike at MikeConrad.com. Just remember, that's Conrad with a K. And be sure to subscribe to the podcast on your favorite podcast app, or if you're watching this on YouTube, click the subscribe button and the bell icon to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of each month. Well, once again, thanks for listening or watching. Stay safe, stay healthy, stay happy, and perhaps most importantly, keep doing it right. and I'll see you again in 2 weeks. Thanks for watching.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.